everyone, I am going to display
Quantum theory of radiation. Before going to know that, we need to know some of the topics like radiation, thermal radiation and its properties, black body, Ferri's black body, energy distribution in the black body. Radiation is heat transfer from source to the object through the vacuum. Here we can take the examples like sun and the earth. So between the sun and the earth there is no medium, so we call it as a vacuum. So without any medium the heat will radiate from sun to the earth. This process is called radiation. Means the sun will emit some of the waves, like whether maybe a heat waves or the EM waves or the infrared waves. So here we are dealing with the heat waves, means the sun will heat up this earth. So sun is a hot body, so all hot body emits heat radiation when the temperature is about 0 degree Kelvin or minus 273 degrees Celsius. So this process is called radiation. So again we have the thermal radiation. It is caused by the heat waves. Means if we are saying that the waves are the heat waves, then this body gets heated up, like the earth become heated, so the objects this earth's temperature goes increased. So we are dealing mainly with the temperature, so it is this radiation is called thermal radiation. And in this thermal radiation we have some properties like, the properties of the radiation, like it travel in a straight line and it also travels with the velocity of light. We know the velocity is that 3 into 10 power 8 meter per second. Means this radiation also occurs the same velocity of light, and it also undergoes the phenomenon like reflection, refraction, total internal reflection, interference and diffraction. Now before going to know the black body radiation, first of all we have to know the basic phenomena, like whenever we are taking a white light, it is fallen on the object, like any object, we are taking any object and it is calling as body, then white light comprises of many wavelengths, because it is not a monochromatic light, it has different wavelengths. Means white light consists of a 7 color, that is a Vibgyor colors: white, violet, indigo, blue, green, orange and red. So due to this, each color have different wavelength. So whenever we are inserting the different wavelengths on the object, that there will be 3 kinds of phenomena, like absorption, reflection and transmission. Absorption is nothing but whenever we are entering this all the light on the object, this all light will be absorbed by the bodies. Means there is no loss of heat here. So reflection is nothing but when whatever the light we are inciding, it get reflected back. So due to the reflection we can see the color of the object. This is one example, like we can see whenever so next is the transmission. Transmission means whatever the light entering onto the object, it will get inside into that and transmit through this object. So this is the basic phenomena. So after knowing this, we can tell you black body. So black body is nothing which will completely absorb all the radiations. Means if we are entering any, if we are suppose some of the radiation to fall on the black body, it absorbs all the radiation, it won't allow any radiations to be reflected or transmitted, it absorbs everything, and it does not reflect the wave, does not reflect or transmit the wave. It only appears like a black because it looks like a black color, because it absorbs everything, whatever the maybe the color of the incident light, but it looks like in a black color. So from Kirchhoff law, he told that a good absorber is also a good emitter. Here whenever we are heating the black body with a heating source, if we are heating the black body, it will emit all the wavelengths. If we are heating the body, it will emit all the wavelengths of, like we are saying that lambda 1, lambda 2, lambda 3, lambda 3, lambda 4. This all the whatever it has been absorbed, it will emit every radiations due to heating process. So this one is called black body radiation, and black body is one body which can absorbs and also emits all the radiation when it is heated up. So there is nothing no perfectly black body, but sun is a very perfectly black body. It will emits and also it will absorbs all the radiations. Actually, when means had hot body is always a good absorber. It will emit and also it will absorbs every radiations. So small one, it is absorption coefficient. Absorption coefficient is nothing, it is that the amount of heat absorbed by the body is whatever the amount of heat we are giving to the body, it will absorb. So that how much of amount we are giving and how much going to be absorbed by the body, that gives us the absorption coefficient. And if we are drawing a graph between the intensity and the wavelength, that particular radiation, it will be like this. When the wavelength is less, the intensity is less. Wavelength is high, the intensity gonna high. And at a particular time, at a particular wavelength, the value is a peak value, which we call as at lambda max, means wavelength is maximum. So here every radiation have some wavelength, but all the wavelengths will, all the lights of all the radiations of different wavelengths will emit, but for every radiation they have little intensity, but for some radiations of wavelength they have the high value, that is a peak value. This is all about the black body radiation and black body. So again we need to go for the Ferris black body. Ferris black body is nothing, it is also one example of the black body, means it has done experimentally to know how it is observed and how it can emit the radiation. So here the black body, Ferris black body, consists of double wall conducting sphere. It is like a sphere, doubled wall, and the outer surface of this wall is a nickel polished. It is polished with a nickel substance, and the inner surface is polished with the lamp black. You know the lamp black, okay? So it is the lamp black. Another, here there is a O is a origin, sorry, O is a small hole over through it, and P is the projection point which is opposite to the O. Here the whole the space is free space. Okay, whenever we are incidenting the radiation over to it, it passes through it and it will incident at that point P. So what happens when it entering, it will just go through the all the internal reflection. So here this will reflect here, so this gonna go here, and after reflecting through this will go here and here. This all the radiation will undergoes multiple reflection, and here all radiation get absorbed through the whole body. So there is no loss of heat due to this, means they won't allow, means this projection P not allowed any of the wave to be radiate out from this Ferris black body, okay? And this will absorb all the body, all the radiations which are incident on it. Whenever we are heating again, whenever we are going to heat this Ferris black body, it will emit all the radiation whatever it will absorb, means wavelengths, with different wavelengths it will emit all the wavelengths. So this is all about the Ferris black body. It is one of the example of the black body, which is explained practically. Using this we can get the black body. Next one is the energy distribution in the black body. Before knowing that, we have to know Stephens. Stephens also gave one thing, that he only given the energy, total energy of the black body, but he doesn't explain the energy distribution in the black body. So from the Stephens law, he gave that total energy of the black body is proportional to the T power 4. T power 4, T is nothing but our absolute temperature, which is measured with the kelvins. So E is equals to sigma power T power 4. If we are removing the proportionality constant, we get a constant term, that is a sigma. Sigma is nothing but a Stephens constant, whose value is equals to 5.67 into 10 power 8 Weber per meter square, K power minus 4. Actually, he doesn't explain the energy distribution of in the black body radiation. So later on, Lummer and Princeton in 1899, they have explained the energy distribution in the black body practically. So there is experimental setup for that. Here the experimental setup consists of a black body, concave mirrors M1, M2, a prism, and another mirror M3, here the bolometer and the galvanometer. Bolometer is the instrument which is used to measure the power of the electromagnetic wave whichever is incident here, and galvanometer is nothing, it will shows deflections due to this all the waves which are emitted. So experimented is like that, the radiations from the black body will incident on the first mirror M1. So this incident rays will pass through the slit. This slit is used to make the rays in a parallel manner. So passing through the slit, the rays become in a parallel manner, and again after passing through the mirror M2, they will reflect it to the prism A, B, C. Here prism, we know the phenomena of prism. Whenever a light passes through the prism, there will be a process called dispersion. So dispersion is nothing but the splitting of light into several colors. Whenever a light will transform, it splits up into 7 color, that is a Webster color. So here all the colors will be splitting up, and they are allowed to fall on this mirror M3. Here also reflection occurs. This reflection is absorbed by this bolometer, and the galvanometer deflection shows. This process continuously goes on for different temperature but for same wavelength. So this under this process it's going on like taking this, but the temperature is going in changing the temperature only for the same wavelengths. This process going on until for many temperatures. So then we will draw a graph between the intensity and the wavelength. So here we are taking the graph between the intensity and the wavelength. So we can see for different temperature there will be a change in the intensity and the wavelength. So if we are taking the temperature 1646 Kelvin, the graph is changing. There has a maximum peak value, maximum peak wavelength, and coming to this 1469 it is different, and here 1259 is different, 1095 is different, and 904. So this is the graph representing the intensity and wavelengths for different temperature. After that we get some experimental result. After doing the experiment, get the experimental results like total energy of the radiation at any temperature can be given as E equals to 0 to infinity E lambda d lambda is the E lambda is energy, and d lambda is the wavelength, change the wavelength, which is equals to sigma t power 4. It is a Stephen's law. Is given by E equals to sigma t power 4. And second result is lambda Tm equals to constant. Here lambda m is nothing but our maximum wavelength, and T is the absolute temperature, and this law is called Wien's displacement law, which is given by Wien scientist, and this is called Wien's displacement law. And another one, emission from the black body at any temperature is composed of radiation of all wavelengths. Whenever a black body is emitting a radiation, there will be a different wavelengths. Not a single wavelength, it will radiate all the wavelengths at any different temperature. Thank you for watching this video.